Welcome back to my channel, everyone. Today, we're diving into groundbreaking research that expands our understanding of viruses capable of persisting in semen and their potential for sexual transmission. This topic is not only fascinating but also crucial for public health, especially as we face emerging and re-emerging viral threats. Let's break it down step by step. For decades, scientists have known that certain chronic viruses like HIV and herpes can persist in semen, posing a significant risk for sexual transmission. However, more recent discoveries, such as the ability of Ebola and Zika viruses to infect the male reproductive tract, have shown that even acute infections can evade immune system clearance and linger far longer than previously thought. A new study published in The Lancet Microbes sheds light on this issue, identifying 22 viruses that can persist in human semen after infection, with 9 showing direct evidence of sexual transmission. This research highlights an underappreciated aspect of viral infections, the establishment of latent infection in the male reproductive system. Viruses capable of this can evade the body's immune defenses, allowing them to persist and even be shed in semen for extended periods. According to Caitlin Play, a lead researcher from the Charité Center for Global Health in Berlin, understanding the dynamics of semen-borne virus transmission is vital for addressing public health challenges, especially during outbreaks of high-risk pathogens. Among the viruses identified in semen are well-known threats like Marburg, monkeypox, and West Nile virus, all of which are now suspected or confirmed to be sexually transmissible. Interestingly, while evidence of viruses like Crimean Congo hemorrhagic fever or hepatitis A in semen is still lacking, researchers believe these could also potentially spread through sexual contact. On the other hand, SARS-CoV-2, the virus responsible for COVID-19, has been detected in male reproductive tissues such as the testis and prostate, but no evidence yet suggests it can transmit sexually. One of the most alarming findings from the study is the variability in how long different viruses persist in semen. This persistence is influenced by the type of virus and the individual's immune health. Men with weakened immune systems, for example, are more likely to experience prolonged viral shedding. Ebola and Zika viruses are extreme examples, persisting in semen for over 2 years in some cases, while viruses like West Nile and dengue are detectable for only 3 to 5 weeks. A particularly noteworthy discovery is the presence of replication-competent Oropouche virus in semen, which raises concerns about its potential for sexual transmission. The Oropouche virus has been linked to complications in fetal development, and its recent outbreak in Central and South America underscores the urgent need for further research. This finding aligns with the study's broader message: many viruses capable of infecting the male reproductive system remain under-researched. The implications of these findings extend beyond sexual health. Persistent viruses in semen could pose risks for reproductive health, including infertility and transmission of infections to sexual partners or offspring. This raises critical questions for vaccine development and antiviral treatments, as current strategies may not fully address the unique challenges posed by semen-borne viruses. Another takeaway is the role of environmental and societal factors in virus persistence and transmission. Outbreaks of viruses like Ebola and Zika in regions with limited healthcare infrastructure underscore the need for global collaboration. Public health interventions must prioritize education and access to prevention methods like condoms, especially in outbreak-prone areas. The study also highlights the importance of monitoring viral persistence during and after outbreaks. For example, while the immediate focus during an outbreak is often on controlling acute cases, long-term surveillance is essential for understanding how viruses like Zika and Ebola continue to pose risks through alternative transmission routes like semen. As researchers continue to uncover the complexities of viral persistence, new challenges arise for vaccine developers. Vaccines designed to prevent systemic infections may need modifications to target viruses that establish reservoirs in reproductive tissues. Similarly, antiviral drugs may need to be tailored to penetrate these reservoirs effectively. While this research provides invaluable insights, it also comes with limitations. The study relied on data aggregated from previous studies, meaning the researchers couldn't analyze individual-level data. This makes it harder to account for variations in how different people respond to infections, but the findings still provide a strong foundation for future research. Moving forward, researchers like Caitlin Play advocate for more detailed studies on how viruses interact with the male reproductive system. This includes exploring why certain viruses persist longer and how to develop treatments that target these persistent infections without causing harm to the host. In conclusion, this study opens new doors in our understanding of viral persistence and transmission. It underscores the complexity of infections and the importance of considering all potential transmission routes, especially for high-risk pathogens. With this knowledge, we can better prepare for future outbreaks and protect global public health. Thanks for tuning in. If you found this video informative, don't forget to like, share, and subscribe for more updates on cutting-edge science and health news. Let me know in the comments your thoughts on this research and what topics you'd like to see covered next. Until next time, stay informed and stay safe.